Okay, so on here, they have this is called the quadratic parent function. This is our equation. Can y'all see that back there? No. Okay. Let me see if I can make this bigger. Now can you see it a little bit? Okay, cool. All right. So we got the quadratic parent function. Here's the equation. And then this description is where most of us kind of stuck. So really quick, this says as x is increasing, so that means as we're moving to the right, y increases. So that on the right side, it's up. Is that true for our picture? On the right-hand side, is it pointing up? Yeah. Okay, let's read the left hand, or this part. Domain values include all rational numbers greater than or equal to 0. So what this is saying is, for your x values, they can only be greater than 0. So are there any negative numbers in our domain? Yes. So does that work for this one? No. Which picture does that one work for? Square root. Okay, so we're going to go ahead and attach it to this guy. I'm going to remove this one. Okay, so the square root is all correct. Okay. Now, let's look at this description. It says one curve, okay, and then it says as x increases, y increases. So that's going up on the right-hand side. That works. As x decreases, y is approaching 0. Is it getting closer and closer to 0? No. Okay, which one of these is getting closer and closer to 0 on the left-hand side? Exponential. Okay, so we're going to take this one, and we're going to move it over to exponential. Okay, and looking at this one, this is all correct. I'm going to go ahead and fold that. Questions on that so far? Okay, this one that we just pulled, one curve, and then as x increases, y increases. That works for this one. As x decreases, my y increases. Does that work for this one? This description, as x increases, y increases, so it's going up. As x decreases, y increases. Is it going up? Yeah, so it works for our quadratic. Okay, we're going to fold this one. Looking at this linear one, it's got the linear parent function. We've got a line. Our equation is y equals x. And with linear functions, it's the only one that has a constant rate or constant slope. Okay, so that's all correct. Now let's look at this absolute parent function. Yes, that's the v. Here is our equation. Let's see what the description is. So it says no curves. Okay, so do you see any curves on here? No, those are mostly straight lines, right? And then it says as x increases, y increases. And as x decreases, y increases. Is that true? Yeah. So we're going to pair it with that one. Okay, just checking over this one. It says as x increases, y increases. That's true. As x decreases, y decreases. That's true. Okay. The characteristic that we're really kind of talking about with those descriptions, this is called in behavior. Okay. This right here describes the ends of the line. Does that make sense? Whenever you're looking at it, you almost want to start and act like you're standing right here and then look to the right and then look to the left and see if it's going up or down. Does that make sense? So for end behavior, you're starting in the middle, you look to your right, then you look to your left and see if it's going up and down. Okay. Questions over this? Is that helpful? Did you correct your own? Or do you need a second to finish correcting it? Here, I'll put all of them out so that you can fix it. Yeah. All right, take a moment. If you need to fix that, that's fine. Okay. So Which one demonstrates the way that Amazon packages are delivered? How many of y'all say option 1? How many of y'all say option 2? Okay, why option 2? Good. One box can't go to 2 houses. Okay, so you're talking about probably this one. Okay, so you couldn't share a box with like your neighbor. That'd be weird. Like one of you bought that Amazon package, right? Also, that would be like wrong. It's wrong. Okay, so option 2, right? Fantastic. Okay, so today we're going to talk about functions and we're going to talk about function notation. Okay, so go ahead and flip that page. A function is a relationship between two variables where every x value has a y value. And we're going to use the word distinct y value, has a distinct y value, because that's going to be real important in a second. The relationship between two variables where every x value has a distinct y value. This is a side note. They might use the terms input and output instead of x and y. All right, so if we want to test whether or not it is a function, we can look at the ordered pairs. We know what ordered pairs are. That's where we have those parentheses and we have an x and y value. That's an ordered pair, right? Okay. If x values repeat, then it's not a function. So thinking back to our Amazon packages, you said, hey, I can't have one box go to 2 different houses. Well, that one would not be a function. Yeah, that option 1 was not a function. Option 2 was. Okay. If I'm given a graph, I can draw a vertical line. And if the graph passes through that line twice, it's not a function. Okay, so those are the 2 different ways that you can test that. They always ask a question about this. There's always one question on either your interim or your final about this. Okay, so just a heads up. All right, so looking at this, I'm gonna help you with number 1, and then I'll give you a little bit of time to practice the other one. Determine whether the following are functions. So looking at our ordered pairs, are there any x values that repeat? Now, just a reminder, the x value is that first one. Are there any x values that repeat? No. What are you gonna say, no? Okay. All right, so they don't repeat, right? So that is going to be a function. Okay, looking at the next one, is that guy a function? So looking at our x values, do they repeat? They do repeat, so does that make it a function? No, so not a function, right? Okay, so do we see how this x value repeats and it has 2 different y values? That's no bueno in math. Okay, can you take a second and do 3 and 4? Okay, on number 3, somebody tell me, is that a function or not a function? Not a function. Okay, and why? There's 2 negative 3, so we see that right here and right here. Cool. So not a function. Over here, is that a function? Yes. Cool. Simple. There's always one question like this. So let this be the easy thing. Okay. If there's repeat of x's, not a function. Gucci? Cool. All right, now we're gonna look at it in tables, which it's very similar to what we just saw, but now it's just a little bit organized a little differently. Okay, so looking at this, we're trying to determine if it's a function or not. Looking at our x values, do they repeat? Yeah. Yeah, which one repeats? 3. Okay, so since 3 repeats, oops, that's a little weird, then it's not a function. Okay. Can you try number 6 and 7? You're only looking at the X column. All right, so for this one, is it a function or not a function? It's a function. Okay, what about this one? Function. What about this one? Not a function. Those 4s repeat. All right, this one always tripped me up as a kid. Sorry, not calling all kids, but this one always made me kind of like, wait a minute. But what you want to look at is this is your X values. It's just like a table. It's just written a little differently. So are all of these X values going to a Y value? And there's no like branching off from the same number, right? Okay, so this would be a function. Bless you. Over here, we see that there's this -1 and it's branched off into 2 different places, right? The same Amazon package can't go to 2 different houses, right? So that's going to be not a function. Does that make sense? On the SAT, I know that's like years out from y'all, but on the SAT, they asked some question like this. Okay. They go, hey, is this a function or not a function? Okay. Right. Now, graphing. Yay. All right. So with graphing, remember, we're going to use that vertical line test. Okay. So looking at this, if we draw a vertical line, are there any points that pass through twice on that line? Yes. So that's going to be not a function. And we could draw that vertical line anywhere. But if it passes through 2 points, then it's not a function. So again, these 2 make it the not function. Can you look at number 12 and tell me whether or not it's a function or not? It is a function, okay? Oh, okay. It is a function, okay? Because when we draw that vertical line, it doesn't pass through 2 points, right? What about that last one? Why? Okay, exactly. Simple stuff, right? All right. So mathematicians like to be extra just a little bit. They like to make things complicated for no reason. They like to confuse people because if they keep you confused, then they're the smartest person in the room, right? Like that's how mathematicians work. So with that being said, we're going to write this stuff out in function notation. This is really just to try to trip you up. That's it. Okay. You know how like you probably have a name and then you have like some type of nickname, either like a completely different name or like somebody shortened your name. Like my name's Taylor. My first name's Taylor. And my parents call me Tay, or they call me Tink because that's my family nickname. Well, the same thing is happening with function notation. It's just a different way to call the same function. Okay. Again, trying to just be extra. So function notation. How we're going to do that is we're going to say f of x, and we're going to say equals 2x minus 8. So we took this, and all we did is replace this y with f of x. Okay, the reason why we write it this way is because this is read as the function of x. This f of x is the function of x. That means that you can plug in an x value and get an output. Okay, so like let's say for instance, I wanted to do f of 1. This is saying the function of 1, right? So I would take 1 and I would plug it in for this x and then solve. Okay, and we're going to see that on the next slide in just a second, okay? So on this slide, we have f of x equals x plus 7, and we're going to evaluate these functions. Okay, so this says f of 5. That means that I'm going to take 5 and I'm going to substitute it in for this x right here. So 5 plus 7. What's 5 plus 7? 12. So that means that f of 5 equals 12. That's all that's saying. Cool. On the next one, it's saying f of -1. So instead of this x, we're going to write -1 plus 7. And what's -1 plus 7? So f of -1 equals 6. Can you try C? So f of -3, I got 4. Is that what you got? Yeah. Okay. Easy enough? I hope so. You're like, this is boring. Good. Okay. All right. Moving on to this next column. They're trying to make it a little bit more challenging because they're adding in this multiplication here. Okay, so same thing that we're going to do. We're going to take this 1 and we're going to plug it in here. Look at how they wrote this, though. They put g of x. That's okay. They're just naming this g instead of f. Does that make sense? Okay, don't get caught up in this. This is just saying, hey, in this function, we're going to name it g. This function's name was f. Cool. Okay, so we're going to take 1 and we're going to plug it in here. So we got 3 times 1 minus 8. What's 3 times 1? And then 3 minus 8 is, okay, so g of 1 equals -5. Can you try B and C? All right, let's see if y'all got it right. What did y'all say the answer was? -17? Okay, so let's check. So we have -3, and we're plugging it in for x. So 3 times -3 is -9 minus 8. -9 minus 8. Since they have the same sign, we're going to add them together and keep the sign, right? So that's going to give us -17. Good. How many of y'all got that right? Cool. Okay. All right, on the next one, we're going to plug that one in. So we're plugging 0 in for x. So we got 3 times 0 minus 8. 3 times 0 is 0 minus 8. 0 minus 8 is -8. How many of y'all got that one right? Good. Okay, we don't even need a calculator. Look at y'all, killing the game. The next one's a little tricky just because it has fractions. Let me make your life a little bit easier, okay? Most of y'all probably have already tried this one. We're going to take -3 and we're going to plug it in. We're going to keep that 2/3 the same. And we're going to multiply it times -3. And then we're going to subtract 1. Looking at this up in the top, what's 2 times -3? Okay, and -6 divided by 3 is -2. I'm going to write this a little bit lower. -2. And then we're still subtracting 1, right? So what's -2 minus 1? -3. So this guy is -3. Can you try B and C? When you multiply this out, just multiply it in the top and then do whatever is in the bottom. Like divide by whatever is in the bottom. multiply the top first, and then divide by what's in the bottom. If you're not sure, use Desmos. Like if you're like, I'm just bad at fractions, fine, use Desmos. All right, so checking your work. I got -1 on B, and then I got 5 on C. Well, anybody who needs me to walk you through that one. Are you okay on that? Okay, another way you could have done this is literally type it straight into Desmos, put these parentheses in, and it does it for you. Okay. Again, I'm trying to make this as easy as possible. There's no reason why we should get these ones wrong. Okay. They're like easy money. Okay. All right. They're making it a little bit more complicated. So now we've got this -1/2, right? Same thing that we did on the last one. So we're going to substitute in that -8. So we're going to have -1/2 times -8 plus 9. What's -1 times -8? +8. And 8 divided by 2 is what? What's 4 plus 9? 14. Ta-da. Okay. Biggest mistake that people make is they forget this negative out front. Just kind of group it with that top number and then multiply it times that number that's in there. Can you take a second? Can you try B and C? All right, so let's plug in -2. So I got -1/2 times -2 plus 9. -1 times -2 is going to give me a +2. And then 2 divided by 2 is 1. 1 plus 9 is 10. Y'all good? Uh-oh. All right, we're going to plug in 0. -1/2 times 0 plus 9. -1 times 0 is 0. 0 divided by 2 is still going to be 0. And then 0 plus 9 is 9. I mean, I got that last one right. Y'all. Okay. Questions over this? Again, if it's easy, good. That's what I want math to be. Okay. All right, on this next one, we've got 2 minus 4 times -5. Well, -4 times -5 is going to give me 20, right? So we've got 2 plus 20, and 2 plus 20 is just going to give me 22. I don't know about you. Do y'all like Taylor Swift? No? Yes? Okay, how many are like, yeah, Taylor Swift? No? Okay, cool. Thanks, guys. All right. I think she got some good music, you know? Okay, so we got -2 and we're plugging it in. So we're going to get 2 minus 4 times -2. -4 times -2 is going to give me a +8. So 2 plus 8 is going to give me 10. I saw a lot of people got 10 for this one. So that's great. Okay. All right, for the last one, this is where a lot of people made some mistakes because I was seeing some weird things as I was walking around. 2 minus 4 times 4. Since this guy is positive, we have -4 times 4, which is going to give us -16. 2 minus 16 is going to give us -14. I didn't see this as often as I should have. Be mindful of your negatives. What was your question? You good? Okay. Remember, positive times negative is negative. That's like if your friend's being negative and you're positive, they're going to bring you down, right? Okay. If you're ever unsure, use that Desmos. Yay, graphing. Okay, this is going to be on your mastery check. This is going to be on your test. This is going to probably be on your interim. This will probably be on the final. Okay, so you need to know how to do this from a graph. It's the same thing as what we just did. You're just using that graph, okay? So we're saying right here, take the function and plug in x is -4. So we're looking at when x is -4, what's our y value? Okay, so starting from 0, 0, which is right here, we're gonna go to the left 4. Okay, so 1, 2, 3, 4, and we're gonna meet it at the line. What y value does that have? 1. So this would equal 1. So we need to go through the second one, or you want to try it? I'm hearing some crickets. So let's go through the second one. F of 2. This is saying when x is 2, what's y? So we're going to start at 0, 0. We're going to go over 1, 2, and we're going to go down to where it meets the line. So what's our y value? 1, 2, 3, 4. Okay, that's okay. We're going to go down 1, 2, 3, 4, 5. So this is negative 5. You see it? Can you try the last one? If I have x is 0, that means I'm going to start at 0 and not move left or right. I'm just going to meet it where the line is. What's our y value? 1, 2, 3. That's going to be y equals negative 3. Cool. So we want to try one more. Okay. Let me give you another one. Let's do f of negative 2. Try to see if you can find that one out. F of negative. Okay, so we start at 0, 0, and we go to the left, 1, 2. We meet it at the line. What's our y value? Negative 1. Okay, let it be easy. If you struggle with graphing and we want to work on it, that's okay. We can chat. We're going to get a little bit of practice on the second part. Okay, word problems. Yay! Yay! This is definitely going to be test. Okay, there is definitely one question that is like this. Okay, so bear with me, okay? I hate reading just as much as the next person. Actually, I really do like reading. I don't like reading math problems. Reading math problems sucks. There's always like some guy with like a bunch of watermelons and like, it's weird. Anyways, so anthropologists use the length of certain bones of human skeleton to estimate the height of the living person. One of these bones is the femur. Do you all know where the femur is? Where is it? It's near your foot. It's like, I think it's this one or it's down there. I don't know. One of the two. To estimate the height in centimeters of a female with a femur length of x, the function this can be used. Find h of 46. So what is this asking us to do? Find h of 46. Find h of, okay, so what does that mean? What am I gonna do? Okay, so we're gonna take 46 and plug it in for x, or multiply 2.32 times 46, and then we're add that 61.41. So we're gonna take this equation. We're gonna say h of 46 equals 61.41 plus 2.32 times, and we're gonna plug in 46. All right, I'm gonna need your help because I don't know how to do this in my head. You pull up Desmos and you tell me what 2.32 times 46 is. We're pulling up Desmos. We're saying 2.32, or multiplying it times 46. That might help me out. Be about, what is it? 168.13. Oh, that's after you multiplied and then added it? Okay. 106 what? 0.72. And then we're going to add that to 61.41. What do you get? 0.15? 13. I can lift it, I promise. Ta-da! So what does this mean? There you go. Say it again. The height in centimeters of the female. So he said the height is 168.13 with a femur length of 46. Remember, up here at the top, they said femur length of X. So whatever you get for X, that is your femur length. So they gave us that, which was 46, right? This is the femur length. That's what we plugged in. The product or the output that we got, that was the height. That is on your test. Interpreting what f of whatever it is. Okay? Make sure that you pay attention to the wording. What I used to do is I used to look for wherever it said X and circle whatever the sentence was right before it. And then I would say, here's the equation. And then I would look for whatever the product is. So for instance, it says to estimate the height of centimeters of a female. So that's what I'm finding. Okay, highlight the important part when you're reading a long paragraph. Okay. Look at that awesome straight line. So good. Okay, go ahead and take a moment. Go ahead and do these four. Go ahead and do these four. All right, so on this first one, we have X is -4. Remember, we always start at the origin and then we move over 1, 2, 3, 4. We meet it at the line. And so this is going to be f of -4 equals, okay. On the next one, we got f of 0. Well, here's my origin. I'm not moving anywhere because it's 0. Well, what's it? What is it? 0. Okay. Again, starting at the origin, we're going to go X is 2. So we're going to go to the right 2. So 1, 2. We're going to go down to where it meets the line. What's our Y value? -2. Okay, so now that I've done those three, can you take a moment and do D? If you didn't already get it done. Take like 10 seconds. All right, so I got -1. Is that what you got? Okay, fantastic. Look at y'all. Okay, go ahead and open your laptop and go ahead and go to student.desmos. There is an activity called function notation. It's not super long. Should be okay. Let's go. Dashboard. Yeah, already on it. Too good. Okay, I only want you to do the odd slides. You don't have to do all of them. I only want you to do the odd slides. Okay, so that means you're going to do slide 1, slide 3, slide 5. Okay, slide 7, slide 9, slide 11. Does that make sense? Okay, so don't do every single slide unless you're just like, I just want to. I'm going to give you about kind of 10-ish minutes to kind of work through this. And then we're going to move on to one more thing. Okay, so go ahead and take a moment. You're working on that. You're doing the odd slides.